Hi there. In this video, we'll discuss about AP Pre-Calculus math subject, and more precisely about the topic 1.1, which is called by change in tandem. And before we actually explain what tandem is, we need to cover some prerequisites, some prior knowledge. We'll begin with the definition of ordered pair. So, an ordered pair is actually any expression of the form x, y. For example, 1.3 is an ordered pair, -1 and -1 is another ordered pair, square root of 2 and 1/2 is an ordered pair, and so on and so forth. In each ordered pair, let's say this x and y, x is called input value, while the y is called the output value. So, for example, in the ordered pair 1, 3, 1 should be referred to as the input, and 3 should be referred to as the output value, respectively. Now, by using ordered pairs, we can present an extra definition, which is that of a mathematical relation. A mathematical relation is any set, and by set we mean any collection of ordered pairs. So, in more simple words, if we gather up at least one or more ordered pairs, then that's how we create a set which is called a relation. Usually, relations are notated by capital numbers. Let's see an example. Write two random relations between two sets. Okay, it could be the relation 1, which contains the 1, 3, the 1, 2, and the 1, 1, or it could be a different relation that includes these numbers, -1, 0, 0, -1, 5, 10, or 5 and 10. In a relation, if I create a set of all input values from the ordered pairs, then this is called domain of the relation. And if similarly I gather up all output values, I create a new set which is called range of the relation. So, for example, remember, all input values of all ordered pairs from a relation create a new set which is called domain. All output values create another set which is called range. Now, let's see this example where we have a relation with 1, 2, 3, 4, 5 different ordered pairs. We need to form the domain. The domain should be, as I just said, the set that includes all input values. 1, 2, sorry about that. 1, 2, 3, 5, and 1. But look, I should include 1, I should include 2, I should include 3, I should include 5, and I don't really need to include 1 again because we don't double count them. It's still the same item. So we should write here that do not write the same number, whether this refers to an input value or output value, more than once. It shouldn't make any difference. With respect to the range of the relation, similarly, I have to gather all outputs. So I should begin by 3, by 5. There's another 3, but I don't need to repeat that. 1 and 6. Moving on, let's see what a mapping diagram is. It's basically a way to visualize how input and output values are connected. In order to do that, assuming that we have the relation from above, 1, 3, 2, 5, 3 and 3, 5 and 1, and 1 and 6, I should create a set which will be the set, which will be the domain. And like we said, in here, we should put all input values without doing any repetitions. So 1, 2, 3, and 5. Then I should create another set, which will be the range in which I should put all output values, 3, 5, 1, and 6. And then I should connect them based on what was stated in the actual relation. We were told that 1 should be related to 3. So I should connect them with an arrow. 2 should be connected with 5. Another arrow. 3 should be connected with 3 again. It's still fine if we do that. 5 should be connected to 1. And lastly, 1 should also be connected to number 6. And there it is. That's the mapping diagram in that specific relation. We have another example as well. Once again, in order to create the mapping diagram, I should create the domain in which I should put all the input values, starting with 1, then with 2, then we have 4, we have -5 and 0. Here we didn't have any repetitions, so we will consider them all anyways. Another different set in which we will include all the outputs, 6, -1, 11, 2, and there's a second 2, but we said do not repeat numbers. And now I will simply connect them with arrows. From 1, it should go to 6. From 2, it should go to -1. From 4 to 11. From -5 to 2. And from 0 to 2 as well. I think it's a quite easy process. Now, based on each relation, because basically a relation has no restrictions. As long as we create a set that includes ordered pairs, we're fine. That is a relation. And the mapping diagram, we bring up together all input values, we bring up together all output values, and then we connect them through arrows. This means that there should be different types of relations. And here they are. It could be a many-to-one. Many-to-one would mean that that many input values are connected to the same output value. This could be like that. We have this connected to that output value and this connected to that. One to many. One input is connected to more than one outputs. It could be just in 2, it could be in more than 2, we don't care. As long as it is in more than 1, it is called one to many. 1 to 1. Each input value is connected to a different output value. In other words, different inputs are related to different outputs. A one-to-one would look like this. This is connected to that, this is connected to that, this is connected to that. Onto. Onto is when for its output value there is at least one input related to it. So, for instance, this means, in more simple words, that I used all the output values. No output value was left. So this is an onto, but look, a non-onto relation would be this. From here to there, from there, this was left out. So non-onto. And that was all. Remember, the key parts we saw in this video. Ordered pair is anything in the form x, y. The x is called input, the y is called output. We bring up together many or even one. We bring up together ordered pairs. That's how we create a relation. In a relation, it would make sense talking about the domain and the range. What's the domain? The domain is the set that contains all the input values without any repetitions. What's the range? The range is the set that contains all output values, still without any repetitions. And finally, by having a relation, I can easily create its mapping diagram. We create two different sets, one for the domain at the left, one for the range at the right, and then we properly place input values in the domain, output values in range, and we connect them based on what was stated from the ordered pairs. Finally, there are different types of relations through the mapping diagrams. We could have many-to-one, more than one input values connected to one output value, one-to-many, one single input value connected in more than one output values, one-to-one, different input values connected to different output values, and finally, we have this special case of an onto, in which we simply need to use all the output values. That was all. If you still have any issues about what we just saw, you are always free to leave your comment below the video. As always, thank you for your time.